In the realm of programming, control flow reigns supreme, dictating the order in which instructions are executed. Imagine a conductor orchestrating a symphony, guiding the musicians through a precise sequence of notes. Control flow statements are the conductor's baton, enabling programmers to craft intricate and dynamic applications. Without control flow, programs would be limited to a linear progression, executing instructions one after another without deviation. However, real-world scenarios demand flexibility and decision-making. Control flow empowers programs to respond intelligently to different inputs, conditions, and events. Consider a simple example. Determining whether a student has passed or failed an exam. Based on the student's score, the program must decide which message to display. This is where control flow comes into play, allowing the program to branch into different paths based on the evaluation of a condition. Control flow is the backbone of programming logic, providing the essential tools to create programs that can adapt, make decisions, and perform complex tasks. In the following sections, we will delve into the fundamental control flow statements in Java, equipping you with the knowledge to orchestrate the flow of your programs with precision and elegance. The if-else statement is the cornerstone of decision-making in Java. It allows programs to evaluate a condition and execute different blocks of code based on whether the condition is true or false. Think of it as a fork in the road, guiding the program down different paths based on a specific criterion. The syntax of the if-else statement is straightforward. If, condition, else. Let's illustrate this with an example. Suppose we want to determine if a number is even or odd. Int number equals sign 10, if number %2 equals sign 0, else. In this code snippet, the condition checks if the remainder when is divided by 2 is equal to 0. If the condition is true, indicating an even number, the message "the number is even" is printed, otherwise the message "the number is odd" is printed. While if-else statements excel at handling binary decisions, switch case statements provide a more elegant solution when dealing with multiple possible values for a single variable. Imagine a light switch with multiple settings, each corresponding to a different level of brightness. The switch case statement operates in a similar fashion. Int day of week equals sign 3, string day name, switch, day of week. Case 1, day name equals sign Sunday, break, // cases for other days of the week, default day name equals sign invalid day, break, system out println, today is plus day name plus. In this example, the variable represents the day of the week as an integer. The switch statement checks the value of and executes the code associated with the matching case label. The ternary operator, represented by the symbols, offers a concise way to express conditional assignments. It's a shorthand notation for a simple if-else statement, often used when the logic is straightforward and can be condensed into a single line. The syntax of the ternary operator is as follows. Condition, value 1, value 2. This expression evaluates 2 if the is true and otherwise. Let's consider an example where we want to determine the maximum of two numbers. Int num1 equals sign 10, int num2 equals sign 20, int max equals sign num1 num2, num1 num2 system out, println, the maximum number is plus max. In this code, the ternary operator checks if is greater than. If true, the value of is assigned to the variable, otherwise is assigned. Section 5. Embracing repetition with loops. Loops are the workhorses of programming, enabling us to execute a block of code repeatedly until a certain condition is met. Imagine a factory assembly line where a specific task is performed on each item as it moves along the conveyor belt. Loops provide a similar mechanism in software, allowing us to automate repetitive tasks efficiently. Java provides 3 primary types of loops. For loop, ideal for iterating a specific number of times. While loop, suitable for repeating a block of code as long as a condition remains true. Do-while loop, similar to the while loop, but guarantees that the code block is executed at least once. Each loop type offers a different approach to repetition, allowing you to choose the most appropriate one based on the specific requirements of your program. In the following sections, we will explore each loop type in detail. Section 6. The for loop. Iteration with precision. The for loop is the go-to choice when you need to repeat a block of code a predetermined number of times. It's like setting a timer for your code, instructing it to execute a specific number of iterations before moving on. The syntax of the for loop is as follows: Java for, initialization, condition, increment, decrement. Let's break down each part of the for loopy initialization. This statement is executed only once at the beginning of the loop. It's typically used to initialize a counter variable. Condition. This expression is evaluated before each iteration. If the condition is true, the loop continues to execute. If it becomes false, the loop terminates. Increment, decrement. This statement is executed after each iteration and is responsible for updating the counter variable. To illustrate the for loop in action, let's write a program to print the numbers from 1 to 5, Java for, int I = 1, I = 5, I++. In this example, the initialization statement declares an integer variable and initializes it to 1. The condition checks if the value of is less than or equal to 5. If true, the loop continues to execute. The increment statement increments the value of by 1 after each iteration. Section 7. The while loop, conditional repetition. The while loop provides a more flexible approach to repetition, allowing you to execute a block of code as long as a specified condition remains true. Think of it as a tireless worker, who continues to perform a task until instructed to stop. The syntax of the while loop is simple. Java, while condition. As long as the evaluates to true, the code within the loop will be executed repeatedly. It's crucial to ensure that the condition eventually becomes false. Otherwise, the loop will continue indefinitely, resulting in an infinite loop. Let's demonstrate the while loop with an example that calculates the factorial of a number Java int number = 5, int factorial = 1, int I = 1, while I = number, system out println, the factorial of plus number plus is plus factorial. In this code, the while loop iterates as long as the value of is less than or equal to. In each iteration is multiplied by and is incremented by 1. The loop continues until becomes greater than, at which point the factorial has been calculated. Section 8. The do-while loop guaranteed execution. The do-while loop is a close relative of the while loop with one key difference. The code block within the loop is guaranteed to execute at least once, even if the condition is initially false. This characteristic makes the do-while loop suitable for situations where you need to ensure that a certain action is performed at least once. The syntax of the do-while loop is as follows: Java do, while condition. Notice that the condition is evaluated after the code block, ensuring that the code is executed at least once. Let's illustrate the do-while loop with an example that prompts the user to enter a positive number, Java int number, scanner = new scanner, system.in, do, while number = 0, system out println, you entered, plus number. In this code, the do-while loop repeatedly prompts the user to enter a positive number until a valid input is provided. The loop continues to iterate as long as the entered number is less than or equal to 0. Section 9. Conclusion. Mastering control flow. Control flow is the lifeblood of programming, empowering us to create dynamic and responsive applications. From simple if-else conditions to intricate loops, control flow statements provide the essential tools to orchestrate the execution of our programs. In this essay, we embarked on a journey through the fundamental control flow statements in Java. We explored the power of if-else conditions for decision-making, the elegance of switch case statements for handling multiple choices, and the conciseness of the ternary operator for conditional assignments. Furthermore, we delved into the world of loops, discovering the precision of the for loop, the flexibility of the while loop, and the guaranteed execution of the do-while loop. Each loop type offers a unique approach to repetition, allowing us to automate tasks and solve problems efficiently. By mastering control flow, you gain the ability to craft programs that can adapt to different scenarios, make informed decisions, and perform complex operations. As you continue your programming journey, remember that the principles of control flow are universal, transcending individual programming languages and forming the foundation of computational thinking. Embrace the power of control flow and unlock endless possibilities in the world of software development.